What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Claire Gandee with me. Claire, can you give us an introduction?
Well, absolutely. Good afternoon. Good morning. Oh, terrible. Why did I say that? It's a podcast.
It's close.
It can be any time of day.
It doesn't matter. Yeah.
Claire Gandee. I am the sales engineering manager with a company called Bekaert. We are a global manufacturer of millions of things. But me personally, I started my career as a structural engineer, and through the economic downturn back in 2008, found my way into a technical sales role. I worked for 9 years at a software company that specialized in post-tension concrete, and since then have been with Bekaert for almost 4 years as an expert in steel fiber reinforcement and flooring and flat work.
Nice. Yeah, so I was sharing with you, we've had fiber folks on before, and before I forget, I might have to, if you like doing this, I might have you come back and talk about post-tensioning, because I've been wanting to talk about post-tensioning. Maybe you could dust off those cobwebs and talk about post-tensioning. But today we're going to focus on steel fiber. Sorry to go off on that tangent.
No, I like it. I like it. And you know what? If you wanted to do that, I have a couple folks I might bring in as well who are even more experts than me on post-tensioning.
Cool. All right. We can nerd out about that.
Yes.
But anyways, steel fibers. So what, my experience with steel fibers is very, very little. So you're the company you work for, they're a supplier of it, or is that correct?
That's correct. So we are the manufacturer of the steel fibers, and we ship them all over the world. We're actually in 120 countries with our steel fiber solution. So this is not new, something that we've been doing actually for about 40 years with this particular business line. But we do manufacture and store and supply all of our own materials.
Okay. So just my general knowledge of fibers, they come in different lengths, different diameters, things like that. Is that the same with steel as well?
Yep, absolutely. So different fiber lengths, different fiber types, different anchorage, some of them, there's all different fibers, right? If you start Googling about steel fibers, you'll find all sorts of things out there, and they all look different. Some of them are straight, some have hooked ends, which are like ours. Some are crimped along the length or undulated or twisted. They're all different shapes and sizes. And just like you mentioned, all those different variables will have an impact on how that fiber should be used and how it will perform.
Okay. And how long have steel fibers been around? Is this a recent technology, or has it been around for a long time?
Well, yes and no. So fiber reinforcing, just taking it back to its most basic, fiber reinforcing was actually used by the Romans way, way, way long ago. They put horsehair in their concrete, and that was the first ever application of fiber reinforcement. And since then, it's grown and evolved to include all sorts of different materials like synthetic fibers, glass fibers now even, and the steel fibers that we use. So steel fiber reinforcement, as far as I know, started in the 1960s. That was when it was initially used. And in fact, perhaps as old as, and I'm going to have to double check my dates here, World War II, there was an airfield done with fiber reinforcement. So this is a technology that's been around and growing and innovating for quite a long time, actually.
Wow. Yeah. That you said that, I think the synthetic fiber guy mentioned that the horse hairs when he was on the podcast. It seems like Romans put all kinds of crud in concrete back then.
They were innovators. They were the original. They were pretty amazing with their use of concrete. It really was impressive.
So steel fibers, I guess these days let's talk about why people would use steel fibers. So is steel fibers to replace something, to supplement something? Where normally do you see it used?
Yes to both of those. So the biggest application that I focus on is overground slabs and flat work. That's what I focus on. For the record, I have a team. There's a team at my company that focus on underground applications like tunneling and mining, precast segments, and so on. So, just from my standpoint and my area of expertise, we're talking about flooring and flat work predominantly. But what we do and where we see the absolute best value is by completely eliminating typical rebar or welded wire mesh in slabs. And the way that we can do that is with a really good high-performing fiber, and we take into account all sorts of design considerations. So I, on my end, work with structural engineering community to help design these floors so that you can have a fiber-only solution. But there are different types of fibers out there that might be used for crack control only, for example, and that's totally fine. There are plenty of floors out there who use the fibers that way and basically design the concrete as if it's plain concrete from a design standpoint. The fibers that I work with on the day-to-day, we actually take into account what's called the post-crack flexural performance. So we assume that the concrete will crack, typically in the bottom of the slab section, so what's in contact with the ground, and then that will engage these fibers, which will then give this excellent post-crack flexural behavior that we can count on in design. So why people would use it is because we can, again, in my case, often provide a thinner slab section. So, a lot of the heavier owners out there, let's say automotive, this big battery boom that's going on, all the electric vehicle construction, battery construction, manufacturing facilities, those are really perfect applications for us. Those heavier loaded floors are where we can come in, provide a thinner slab. So that means lower material cost, faster schedule, and lower labor requirement as far as placing these floors. And then you get a really strong, durable, long-lasting floor solution. And in many cases, we can also extend or eliminate socket joints. And so that's, again, for the big manufacturers or where you've got a lot of forklift traffic, sensitive equipment going over joints can be kind of an interesting challenge. So by allowing the floors to extend or eliminate joints can just add to, the value and long-term, let's say, maintenance reduction of a facility. So there's all different types of ways that you can use fibers, and it's really going to be case by case. We try not to say that one size fits all, because there are some situations where I would recommend a combined solution where you would still have rebar or mesh plus fibers. And so that might be, a floor solution that has a lot of restraint, or maybe it needs to be watertight, or, you've got a really tight crack limit where a crack can't exceed, 0.3 millimeters. And so that might be an opportunity to use a combined reinforcement solution. So it would really just depend on what are the requirements of the project, what are we trying to do, what are the priorities, and, look at what's the best fit.
Yeah. And so, just like synthetic fibers, you were talking about ones that are for controlling cracks and some that are for structural means. So is it the same term as micro, macro? Do you all use that in steel fiber industry?
I think the official term for our fibers that we use are steel macro fibers.
Okay.
But I don't think anybody actually says that. It's usually microsynthetic, macrosynthetic, and steel fibers. That's how I've typically seen it indicated in the market.
So there's no such thing as a micro steel fiber.
Somebody is probably going to say that there is, and there may be. I just don't happen to know of that.
So what you're familiar with is the structural use of the steel fiber. So replacing our traditional reinforcement, rebar, mesh, whatever is
exactly.
I gotcha.
Yep. So the shortest fibers that we would use, so we're a Belgian company, my company is, but you'll find that kind of consistently through the fiber world, metric delineation of lengths is really common. So our shortest fiber is 30 millimeters, which is just over 1 inch, and our longest fiber is 60 millimeters, which is about 2.3, 2.4 inches long.
Okay. Now, is there any kind of, since you're the floor expert, and you probably deal with place and finish guys all the time. So I've never personally placed steel fiber concrete before. So is there things that you need to be aware of? Is there certain ways you need to place it? What are the best practices for placing steel fiber concrete?
Yeah, that is such a great question. I'm really glad that you asked that. So yes and no. General rule of thumb is we say, good finishing and placing practices remain, right? We're not trying to reinvent the wheel, but there definitely are best practices that will help ensure, a better likelihood of a great finish and, nice looking joints and so on. So one of those would be really paying attention to vibration and consolidation of the concrete. So we definitely recommend using a laser screed when possible, and also saying, not only use a laser screed, but speed up or increase the vibration at the head, and then use a slow arm retraction. So as you're screeding back, don't go as fast as possible, right? So we really want to make sure that you're vibrating and consolidating that mix really well. And what you'll find is that the fibers do tend to kind of lay down flat towards the top of the section. And when you have a nice mix design with a good amount of paste, that paste will vibrate up over those topmost fibers. So you're really going to be minimizing the amount of fibers that are visible at the top surface. Because that's one big question that everybody asks, are the fibers sticking up all over the surface? Are the slabs hairy? This is probably my number one question that I receive. And no, it shouldn't be the case. Because I think what's happened in the world of concrete and fiber reinforcement is people kind of group all fibers together when they haven't had that much experience or exposure to it. So the synthetic fibers are made of, a polypropylene, or let's call it in layman's term, a kind of plastic material, which is lighter. So it can have a tendency to float up in the mix as it's vibrated. But the steel products don't have that same material composition, so they're less likely to float up. So this is where the mix design, the amount of paste and fines in the mix, as well as the finishing practice will come into play, because the fibers really shouldn't be sticking up. But I'll be the first to tell you, we're a fiber manufacturer. We don't place and finish the floors. We could never guarantee that there would never be a fiber visible at the surface. And I'll even go so far as to say that you shouldn't expect that. For those of you new to fibers in the community, I have seen plenty of floors where you don't see hardly any fibers at all. But the whole point of a fiber reinforced solution is that you have fibers in 3 dimensions from top to bottom in your concrete section. So it is possible that they could be right up at the top, and that shows you that they're everywhere and that they're doing their job. So, I think it's a little bit of a management of expectations conversation around that. But I think, there are certification programs out there. I know, for example, my company does certification. So for a flooring contractor, a concrete sub who really wants to know what is the best way that I can go ahead and load these fibers and execute this floor with the best possible outcome, there are training services out there to help those crews, ensure they get the best possible finish. But we've been doing it for years and years without the certification program. So it's not necessarily a requirement to do it successfully, but now we're just really ramping up that training to give people more peace of mind and more training. So, the floors look even better.
Yeah. And as far as when you add the fibers to the concrete, is it during when you're, let's just say dry batch, you're adding all the different stone and cement and sand and water, and then you rotating the concrete mixer and it's mixing all that stuff up, do you I guess add the steel fibers during that process, or is it do you add it after all that stuff's been mixed together? When do you add the steel fibers?
Both. We see both options. Yeah. So we
Okay.
can see it adding through the batching process at the batch plant. We tend to see it going through at the same time as your large aggregates or towards the end of the batching process. Or we say after your concrete is loaded into the concrete truck, the fiber should be the last thing added to the mix. That's one recommendation from our side. I know other fibers have different recommendations, so I would always say check with the fiber that you're using and check their best practices and recommendations, because they do differ, which is kind of unfortunate because I think it adds to some of the confusion in the marketplace. But just always check with your fiber vendor. They'll be able to guide you on this. But we say the fiber should be the last thing added to the truck, in which case we've seen folks use conveyors or, just a ladder even to get up and kind of dose the fibers right up through the top of the drum mixer. And then, like you said, about 5 minutes of mixing in the truck, which usually, you have at least 5 minutes from the batch plant to the job site if you're doing it that way, or if you're dosing it right on the job site, just let those trucks sit and revolve for 5 minutes, get that nice distribution, and then you're on your way.
Gotcha. And I know you said that on not one project, or there's not like a certain amount of fibers that you put in a mix for all jobs. But what is the range of what I've seen is pounds per yard? What's the range that you typically see for steel fibers?
Yeah, so all fibers are going to be dosed and specified in pounds per cubic yard here in the U.S., around the world, kilograms per cubic meter. So here, I've seen some fibers as low as about 9 pounds per cubic yard and up to about 65 pounds per cubic yard in typical flatwork applications. But there are, other really interesting things going on. I'll just give a quick, example. Out west in the Pacific Northwest, there's a company in the Seattle area called Carey Kopczynski & Company. They're a structural engineering firm that they use these steel fibers in really high dosages, around 175 to 200 pounds per cubic yard. So really, really high density of fibers in shear wall link beams in these very high seismic areas. So basically think of like an elevator core going up, and over the elevator door, you need to have a beam that's linking the shear wall surrounding that tower. And we're talking 30, 40 stories high. So, good size building structures. And the use of that really high dosage of concrete, that's going to be with a self-consolidating mix. So that's definitely going to, we want to have compatibility with the fiber dosage and the mix itself. But what that does is it really improves the workability, the constructability, and the schedule of those typically very, very highly reinforced and congested structural elements. So that's just one kind of isolated example, but just to give you a sense of range, like you asked.
Yeah, that's cool. So they're looking at replacing, I guess, the traditional reinforcement for beams, which
reducing.
would be reducing. Okay, so it's not totally replacing, but reducing.
Exactly. Those are really, really highly reinforced members. And so by using the steel fiber solution, it just reduces the congestion and makes it possible. And it has a lot to do also with schedule, because there used to be these like diagonal X bars that are really common in those beams. And so what that means from a scheduling standpoint is, as you're moving vertically up the building, you have to think very carefully about how you're pouring that right from one level to the next. And now in most cases, we're able to eliminate those diagonal X bars. So from a constructability standpoint, it's a lot easier and faster. You don't have to worry about those bars sticking out into the subsequent pour.
Yeah, no, that's really cool, because when you get on jobs like that, you get so much rebar in there, and there's no room for the concrete. So it's like you get these voids, and then the engineers, you get everybody excited because you got to go back and do some kind of structural patch or something like that. And then you got to, I'm sure as a structural engineer, they're pulling their hair out because they got to figure out what the all kinds of different calculations to figure out if that void is so large to a point where it's detrimental to the overall structure, and yeah, it's no fun.
Exactly. Yeah. So to the extent that you can, I mean, and that's really dependent on this particular structural engineer being very open-minded and very constructability focused, and partnering up with a research lab at University of Wisconsin to do that research specifically on those elements and kind of find a way to improve their building design and construction process. And I think that's a great testament to, you know, what open-minded engineers and the research community can come together to really improve building construction. Because I think that's one of the big challenges that we run into. I'm sure you've heard it too, where we just do things the way we've done things because they've worked more or less in the past. And there's always options to change, and change is scary. I know that too. I'm scared of change as like a human person sometimes. So, you know, there's a bit of a hurdle to get over, and that's just the same as it would be at home as it is on the job site. So, you know, it's totally normal for folks to say, you know, I've never used that. That sounds scary. I'm afraid of it. And I'm here to say steel fibers are not scary. It's totally doable. And the folks who are experts in this can really guide you guys on the way, because there's a lot of money to be made, if I'm being perfectly honest. And there's a lot of performance improvements that are available out there. So might as well get involved in that.
Yeah, just have an open mind and be proactive. We've beat that horse so many times on this podcast about being proactive, but everybody's been in such a rush the last few years because of the demand. Hopefully things slow down a little bit for us, and that we can start taking those proactive approaches and do that favorite thing that we all like to call value engineering, where we get some time to look at some things and try to figure things out if there's a better way to do it. But I totally get with structural engineers being hesitant to do something new because it's their stamp on there, and something goes wrong, it goes back to them. That's why they have that stamp.
Yeah. 100%. And my personal experience, I definitely confirm, you know, that structural engineers have a lot on their plate, and they're responsible for an incredible work product. You know, what they do literally can save or destroy life, and that's an incredible responsibility. You know, we just see what happened with these earthquakes out in Syria and Turkey. So I take really a lot of respect with me when I go into structural engineering firms to talk to them about this. I know they have a lot on their plate. I know they're super busy. I know that folks are just doing their absolute best, especially now in the industrial sector where I'm focused, where goodness, like folks are just so busy. But this really is, I think, a value added thing. And actually we can take some work off your plate if you'll let us. So there's some good opportunity there.
So you're talking about like delegated design as far as slabs and things, where you guys will give a recommendation on a slab design versus them doing the whatever calculations and things.
Yeah, exactly. You know, I've done a lot of research myself and tried to educate myself and my team so that I can actually be a resource and almost like a consultant to my design partners. So to the extent that I can, I want to take work off your plate. I want to help you with the slab design, and I'll give you guidance on, you know, not only what is the recommendation, the slab thickness and dosage, but, you know, the joint spacing, what should the detailing be around the columns or the perimeter of the slab? Hey, have you thought about, you know, one thing that's coming up a lot is the automated racking solutions, the ASRS, you know, racking and a lot of automation and so on. And so because of the experience that I've been able to have over the past several years, I'm able to now ask, you know, maybe an engineer is doing their first one and I can say, hey, you know, this is something, have you thought about this? And this is how we've handled that in the past, and actually really being a resource to them so that they do feel even more comfortable and confident with the solution, because they know that we're coming at it from a standpoint of we're here to support them and their projects. I'll be the first to say, anybody who's just in it to sell fibers, be wary of that. I will be the first one to walk away from a project and say, that's really not a great fit for what we do, or, you know, this seems risky. Why don't we do it this way? Because I would much rather have a relationship that's built on trust and integrity, and knowing that I can sleep at night and you can sleep at night because that project's going to look good, and then we're going to work together again. I mean, that's really what I'm trying to build.
Yeah, it only takes one bad project and you're not going to get any more.
Thanks.
I don't mean to jump around, but I meant to ask you this when we were talking about the fibers themselves. Is there a coating or anything on these to help with rusting or anything like that?
Yeah, so there are both galvanized and not galvanized fibers out there on the market. Our company has both. We also allegedly have stainless steel fibers, but I've never actually used them. I think they're extraordinarily expensive. But apparently they're in our product catalog, so they exist somewhere. But this is actually a really great question. I'm glad you brought that up, Seth, because this is a common recurring question that we receive is, now you've got these fibers all over the place. Is it going to rust all over? Because I think the community who works with concrete and reinforced concrete we've all seen rusted out concrete with spalling and looks atrocious, and you're looking up at the side of a bridge and you see something like that, you're freaked out and you don't want to drive on that bridge. So I totally get that. Actually, there's a number of things. This is a slightly lengthy conversation, but I think it's worthwhile for the folks listening. So because the steel fibers are discontinuous, that's one of the most important ways that it actually improves the overall corrosion resistance. So if you think of corrosion or rust as like an electrical current, so should a steel fiber, let's say an uncoated, non-galvanized steel fiber that's near the surface, let's say that is exposed to some kind of water, chlorides, whatever, and it starts to rust. At most, the fibers are 2.4 inches long and they're discontinuous. So even if that fiber rusts, it's not going to spread that corrosion to its neighbors because they're not touching. Mm-hmm. So it's a localized situation. And then additionally, the fibers are really small in diameter. So our typical fibers are around 0.9 millimeters in diameter, so less than 1 millimeter. And so the spalling that we're used to seeing with rebar solutions, it's because corrosion is actually an expansive pressure. So when the concrete is surrounding the rebar expands as it corrodes and it spalls the concrete. But these steel fibers are so small that actually the corrosive pressure that they exert is not enough to do any damage to the concrete. It basically will just kind of dissolve. You'll see like a little fossil if a fiber is near the surface. So rule of thumb that we see is in an interior application, rust is very uncommon with a steel fiber solution. We've even been in food and beverage, like poultry facilities where they're hosing down the floors with a water bleach solution twice a day, and the floors look great. You don't see anything. But on an outdoor application, so we've done lots and lots of pavements, including port pavements, shipping yards, these giant, container terminals at Port of Savannah and Spain and Portugal and all over the world. We actually use our uncoated, non-galvanized steel fibers in those applications because really the risk is aesthetic only. And I think that's a really important topic to discuss with the ownership of the facility. So there's a agreement and alignment on management of expectations that you could see a rust spot at the surface. There could be a discoloration that's localized, but that's it. There's no structural deficiency. There's no loss of capacity. There's nothing that needs to be repaired. So as long as the folks who are running and maintaining that facility are aware of that and on board with it and understand it, everybody moves about their life, and you've just got a really nice long-lasting facility there. So we tend to see really significant improvement with a steel fiber solution, and sometimes we do use galvanized just because maybe the owner is sensitive to rust spots, and that'll buy you quite a bit of time. But there's a pretty good case to be made for using ungalvanized fibers, again, just depending on the client and the conditions of the project.
Yeah. In the mix design, because there's basically different things that you can do, put in the mix to keep the water out or in the first place. So it's not all the blame on the reinforcement. So
You're right.
Rebar or steel fiber. So what you were saying, kind of the trends of what kind of projects you're seeing right now. You're saying industrial. Could you share with what you're seeing out there? And
yes.
What's getting built a lot?
My company, my team, we focus really on the industrial sector. Less so on the light industrial side. The speculative warehouse market is not necessarily an area that we focus, simply because so many of those floors are unreinforced.
They're cheap.
Speculative guys
are cheap.
I'll let you say it, not me. I mean, they are very cost conscious, that's for sure.
Okay, so you're being nice. You're being
I'm
PC.
being diplomatic. But, where we tend to bring the most value is in the more moderate to heavy loaded applications. Mm-hmm. So the manufacturing, automotive, food and beverage, data centers, and those types of facilities, which of course are all booming right now. We thought there might be a slowdown, and it just doesn't appear to be the case at all. For the record, the automotive sector has been a long-term user of our solutions. We've been really active in automotive projects all over the world for probably 25 to 30 years, because they are really looking for that durability and, high strength solutions and thinner slabs and so on. So that's definitely a great option for us. And what's also nice is, especially in a manufacturing facility where you have to drill in a lot of post-installed anchors, this makes your life a lot easier for those. I'm not going to drop names. I will. Hilti, Simpson, DeWalt, whoever it is who's drilling those anchors, your life is going to be a lot easier when you don't have to coordinate around all that rebar. So that's one big benefit, especially I mentioned the ASRS, the automated racking solutions, where you've got thousands and thousands of uprights that you have to anchor in. It just makes the coordination effort of that so much easier and faster. So I think that those are the sectors that we have been most involved in up until now, is really the moderate to heavy loaded industrial applications. And I guess lucky for us, it's still incredibly busy, but warehouse and distribution centers as well. Again, during the pandemic, where e-commerce became even more prevalent, that was a huge boom as well that we were also involved in, because the speed of construction is, as you know, time is money, right? So being able to place and finish these floors faster, if we can eliminate a single mat or a double mat of rebar, that's buying you some really serious time. And especially on these projects that are 1 million, 2 million square feet, all of a sudden you're saving a month, 2 months on schedule. That's not anything to sneeze at. So there's some real benefits, and owners just love it when they get into their facilities earlier than they expect.
Yeah, that's when they make their money. Mm-hmm. Not while we're building. That's really cool. I was thinking too, when those automotive industrial type facilities, when they're doing, they always build these things, and then they try to think down the line as far as what they're going to have in the facility. But they, I would think often that they forgot something, or something changed, technology changed, and they need to get back into that facility and cut out concrete and make changes in there. And I would, like you said, you don't have to worry about the rebar you're cutting out or anything like that. I could see some advantages there.
Without a doubt. I've been nodding my head the whole time you're saying that, because that's definitely a really common situation for us. I mean, sometimes owners will just call us and say, hey, we have this slab we put in with your fibers 15 years ago, and now we're changing X, Y, or Z. Will the slab be able to handle these new loads in this new location? And that's actually, I think, one of the reasons that some owners are actually moving to these jointless floors. And when I say jointless, I'm talking about no saw cut control joints. They're still construction joints, but those have really incredible flexibility that, you have the same design strength everywhere on the floor. You can move your equipment, like you said, 5 years down the line, or you add in some new fancy robot or whatever it is. You've really got that future flexibility built in. Yeah,
and you don't have as many joints to run over with forklifts and things like that. As a guy that used to work in a warehouse, it always sucked when you're driving a forklift and you going over
Oh yeah.
Yeah, like
Yeah.
or you're trying to pick something 30, 35 feet in the air, and then you got to make sure you're not sitting on a joint or something.
Sure.
Awesome. I think that's a good spot to pause for today, Claire. Thank you for sharing about the steel fibers. I learned something, as I usually do, on these things. So if folks want to reach out to you and learn more about steel fibers, what's the best way, Claire?
Oh, well, you can email me. I guess, do I just put my email
you can
out
just
here?
give it to me. So when I send it the podcast out, I have show notes on there, and I'll put all your information in there. You just tell me what your preferred way is. Some people like shout out their phone number, and I'm like, oh, wow, you just put it out there.
Yeah, I don't know that I'm going to put my phone number in here. I get enough spam calls about my car's warranty. But I think, yes, guys, call, email, text is all fine. You can also find me on LinkedIn. That's a really good way to connect with me. I definitely check that at least once a day. So if you wanted to message me on LinkedIn, I'd be happy to connect with you there. And really, I am so thankful, Seth, for you to have me on here. I really appreciate the opportunity to talk with you.
Oh, no. It's all my pleasure. I appreciate you coming on, and we'll have to, like I said, we'll get you back on here again and talk about PT.
Deal. I'm in.
All right, cool. All right. Appreciate it, Claire.
Take care.
Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9-to-5s, we're out here changing these skylines with wood, iron, and mud. We work hard for a dollar, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star Heat to the woods of the Georgia Pine.